Welcome to the TechStat Google Key Management Service demo. Today is Thursday morning, August 29th, 2019. My name is Conrad Kronak. I'm the Information Security Architect for NTT Data. The majority of cryptographic breaches are the result of stolen keys. As a result, management and protection of the keys is critical. Google Key Management Service accomplishes this objective, and this is a screenshot from their website. You can see that it's protected by FIPS 140.2 level 3. This is the highest level of protection. Please refer to this website for additional information. Now, the setup of this is horrifically complex. I've distilled it into only 14 pages, okay? But this is very actionable. You have to create a project on the cloud. You have to enable billing. You have to enable the API. You have to install an SDK, and on and on and on. This works. Go through this very judiciously, and this will save you a lot of time and all of the pain and agony that I had to go through. Setting the environment variable is really the end result of all that. So this file right here contains primarily the client X509 certificate. And that's what's going to be used on the client side in conjunction with the keys on the cloud in order to protect and decrypt our variables. So the first major component of this is setup. The second is the client-side code. So this has basically 4 variables that defines the keys. And I'm going to show you how to get those. So this is my project out on the Google Cloud. The project ID is right there, and that's the first variable that's going to specify the key we want to use. Then if we go to project settings and down here into cryptographic keys, the key ring name, okay, is web app. So that goes here. And then the key name itself is app secrets. You can call these anything you want, but those are actually good names. The location is global. You just have to know that. I'm telling you that, so now you know. This has been distilled into 2 public methods. One is called encrypt clear text file that we're going to run first. We're going to demo this. And the second is what you're going to use in production. It's called decrypt entire file. Now, in software engineering, encapsulation is one of the most important principles. Encapsulation is simply hiding complexity within a simplified abstraction layer. So you can see I've done that here for you. You only have 2 methods, okay? As far as the code that I provided to do this, there's only 215 lines of code. This is very readable. You're going to be able to step through this and see exactly how this is working. I'm not too sure why a lot of people don't use the concept of encapsulation. It might be that architects want to impress people with their technical acrobatics, or it might be, wow, I've got it working. I don't have the time or the inclination to make this professional. This has been made professional for you, so this will be of great value to you. Okay, now we're going to run the application, and first we're going to run with this Boolean set to false, and that's going to encrypt a file. So here's our working directory. And first you want to set up a clear text file with your secrets. So the example I'm using here is we're going to set up a database connection string. That's a clear text file. So we're going to run this, and it's going to create two other files in here. So we'll launch this. And this is a Java Spring Boot app, so it takes a few seconds here to initialize. And you can see it's created two additional files for us. So again, here's the file we started out with. I'm going to open up encrypted text. So there's our encrypted text. In this file, I just create so that when it gets restored, we can see that the clear text file, which is here, and the restored file after it was decrypted is the exact same. Okay. Now, this was created just for demonstration purposes, so you definitely want to delete this. Okay. And then when you're done, you're going to want to take this file and move it into some protected local key vault, such as KeyPass. You don't want to have clear text passwords, have your secrets anywhere clear text on your development systems or on your servers, and especially not on your production servers. Okay, now we're going to run this again, where the first time we ran encrypt the clear text file and we got our encrypted file here. Now we're going to run decrypt entire file, and this is what you'll use in production virtually all the time. So as we run this one, and you can see down here it successfully decrypted your database connection string and anything else you want to put in there. I recommend just having one file. The less complexity that we have, the more secure our software is going to be. Okay, so now we don't want to just blindly accept, even from Google, that this is secure. We want to prove that it's secure. So this needs a little bit more analysis. I'll be moving on to my next job. My last day on the TechStop project is tomorrow, August 30th. So you're going to want to prove that this is secure, run some diagnostics on it. I'm not sure what that's going to be, but I'm going to be doing that myself. Regarding pricing, this needs analysis also. I believe that the cost is per transaction. So if you use it for database connection strings, there'll only have to be one transaction each time the web application is launched. So this should not be horrifically expensive, but that needs some research also. Okay, so again, here's my contact information. You're very welcome to contact me if you have any issues with this. Thank you very much for listening, and I hope you have the very best results for TechStop Connect going into the future.